Section 1.2.8, Security and Identity, the Invisible Architecture. Let's talk about the one thing that can quietly destroy an otherwise perfect cloud system. Not databases, and not performance, not clever code, security and identity. This is the trust layer of the cloud, the invisible architecture that everything else quietly relies on. Without it, nothing is truly solid. Your system may look like it works. Requests flow, users log in, dashboards are green. Until one wrong permission, one leaked credential, or one careless script knocks the entire structure sideways. That's why identity and access management exists. IAM is the cloud's answer to a deceptively simple question. Who is allowed to do what? Behind that simple sentence sits enormous power. IAM decides which users and services can see which resources, what actions they can take. Reading data, changing configurations, deleting infrastructure. And under what conditions those actions are allowed. From where, at what time, and with what level of verification. If this feels abstract, here is the simplest way to think about it. IAM is not a feature you turn on. It is a decision engine that runs every single time something tries to do anything in your cloud. This is not just about logging in. It's about limiting damage when something inevitably goes wrong. That idea is the key to understanding everything else in this chapter. Because IAM does not exist to stop mistakes. Mistakes always happen. IAM exists to make sure mistakes do not become disasters. And this is where the most important concept in all of IAM appears. Least privilege. Least privilege means that every identity, human or machine, gets only the permissions it needs to do its job. Nothing more, not just in case, not for convenience. Exactly what's needed, and no more. Another way to say this is simple. Permissions are not rewards, they are risk. This isn't theory. It's a lesson written again and again in incident reports. By 2025, the vast majority of cloud breaches were not caused by brilliant attackers. They were caused by identities that were allowed to do too much, permissions that were broad, forgotten, never cleaned up. If you remember only one thing from this section, remember this. IAM doesn't prevent mistakes. It limits how much damage a mistake can cause. Think of IAM as a fire door, not a fire alarm. It doesn't stop the fire from starting. It stops the fire from spreading. Once you see IAM through that lens, it stops being mysterious. Think of it like a secure building. Identities are the badges. Policies are the rules printed on those badges. Where you can go and what you're allowed to touch. Roles are temporary passes you assume for a specific task, and then give back when the job is done. Federation is trusting an external authority, your company login or a trusted provider, so you don't need to manage yet another password. And conditions are the extra checks at the door. Multi-factor authentication, trusted locations, allowed times, different names, same logic. Let the right things happen. Block everything else by default. And here's a point that saves a lot of confusion, especially early on. In the cloud, machines are identities too. And very often they cause the biggest breaches. Your application, your backup script, your container, your background worker, all of them act using identities. When those machine identities are overprivileged, attackers don't need to trick a human. They just wait for a machine to make a mistake, or they find its overly powerful credentials lying around. This is why IAM is just as much about machines as it is about people. If you ever wonder where to look first after a breach, look at machine permissions before human ones. Another common misunderstanding is thinking IAM is only about authentication, proving who you are. That's just the front door. The real danger lives deeper in authorization, what you're allowed to do after you're inside. Authentication answers the question, who are you? Authorization answers the much more dangerous question, what damage are you allowed to cause? Most systems don't fail because someone logged in incorrectly. They fail because someone or something was authorized to do far more than it should have been able to do. There's also a dangerous assumption many people make about the cloud, that the provider handles security. They don't. Cloud providers secure the infrastructure. You secure everything you build on top of it, your data, your identities, your access rules. If you get IAM wrong, the cloud will not stop you. It will faithfully execute your mistake at global scale. So when a request hits the cloud, something like delete this database, IAM doesn't guess. It evaluates. Who is making the request? What action they are trying to perform? Which resource is targeted? And whether the conditions allow it right now. And one rule always applies. Deny wins. A single explicit deny overrides every allow. This means safety beats convenience by design. And that is intentional. That rule exists to protect you from accidents, including your own. Every decision is logged. Who did what, when, from where. That's how auditing and compliance work in the cloud. Not mystery, traceability. If you remember one thing from this part, remember this. IAM decisions are boring by design, and that is exactly why they are safe. Before the cloud, access control was crude. If you were on the internal network, you were trusted. That model collapsed the moment systems became shared, global, and automated. IAM was invented to enforce isolation in environments where thousands of identities coexist, and where one mistake must not destroy everything. Over time, IAM evolved quickly. By 2025, it includes passwordless logins, just-in-time privileges that exist only when needed, continuous verification, and anomaly detection. But here is the grounding truth that cuts through the hype. AI doesn't replace IAM thinking. It just cleans up after human laziness. Tools help, but discipline decides. The tools look different across clouds, but the goal is always the same: shrink the attack surface. On AWS, tools constantly scan for permissions that are too broad and suggest removing access that hasn't been used. On Azure, access decisions react to risk signals like location or device health, and elevated privileges disappear as soon as the task is done. On Google Cloud, IAM observes real usage patterns and recommends tighter roles based on reality, not guesswork. Different platforms, same philosophy. Reduce standing trust, increase verification. If you remember only one thing from this entire section, let it be this. Least privilege is not about control. It is about containment, because when a breach happens, and statistically it will, the impact depends entirely on what that identity was allowed to do. History makes this painfully clear. Major breaches didn't happen because encryption failed. They happened because permissions were too broad. A single overprivileged role, an exposed machine identity, a forgotten access rule. That's why mature teams treat IAM as a living system. Human access is temporary. Machine access is minimal. Nothing lasts forever. Everything is reviewed. IAM is built into the pipeline, not added at the end. When senior engineers talk about IAM, they don't sound dramatic. They sound calm. They say things like, I start from deny all. I grant access based on proven need. I use short-lived credentials. I audit continuously. No buzzwords, just discipline. Picture a well-designed cloud environment. A root account locked away. Production and development cleanly separated. Humans logging in through federated identities with multi-factor authentication. Machines using narrowly scoped service identities. Audit logs flowing quietly in the background. Nothing flashy, nothing loud, just quiet correctness. And that is the real lesson of IAM. Cloud security is not about building walls so high that nothing works. It is about designing systems so that when something breaks, and something always does, the blast radius is small, contained, and survivable. IAM is the trust glue, the invisible architecture that makes modern systems possible. And now that we understand who can talk to what and under which conditions, a final test remains. After one listening, you should be able to explain this in simple words. At this point, you don't need to remember service names or platform details. You need to remember the shape of the problem. That IAM answers who can do what and under which conditions. That least privilege is about reducing damage, not preventing mistakes. That machines are identities too, and often the most dangerous ones. That deny always wins and everything is logged, and that good IAM is quiet, boring, and relentlessly disciplined. If you can explain that, you understood this chapter. And now the next question naturally appears. How do we assemble all of these guarded pieces into complete architectures that are not just secure, but scalable, observable, and resilient as a whole? That's where the story goes next. End of section 1.2.8.